All right, let's get right into it. We're about to talk about one of the most profound, most important unanswered questions in all of science. It's a question that has $1 million bounty on its head, and honestly, the answer could completely change the world as we know it. I want you to just imagine something for a second. What if all the ridiculously complex problems, I'm talking about predicting the stock market, designing a life-saving vaccine, anything you can think of, suddenly became easy? Not just a little bit easier, but like child's play for a computer to solve. That's the world we're about to peek into. In a world like that, FedEx could figure out the single most efficient route for every single package everywhere on Earth instantly. Scientists could design brand new drugs, molecule by molecule, in like an afternoon. And all of our digital encryption, the thing that keeps the entire internet safe, yeah, that would be shattered in seconds. It would be a total game changer. So you have our world on one side, right? A world of good enough, of approximations, of doing the best we can. And then you have this other potential world, a world of perfect, instant answers. The gap between those two is just staggering. And it all comes down to this one single question that nobody can answer.
So, what is this mystery question? Well, at its heart, it's all about the difference between two kinds of problems, which computer scientists have put into two big buckets, P and NP.
Let's start with P. P stands for polynomial time. Now, don't let the name freak you out. All it really means is these are problems a computer can solve in a reasonable amount of time. Think about sorting a list of names alphabetically. You might have 100 names, you might have 1,000,000. It doesn't matter. The computer has a really clear step-by-step recipe to just get it done. No problem. And then we have NP. And this is where it gets really interesting. NP problems aren't necessarily easy to solve, but, and this is the key, they're super easy to check if you're given an answer. Imagine someone hands you a finished Sudoku puzzle. Now, it might have taken them hours of brain-melting work to figure out, but for you to check if they got it right, you can do that in, a minute or two? That's the whole idea behind NP. And that really gets to the heart of it all, solving versus checking. For a P problem, finding the answer is easy. But for an NP problem, like finding the absolute shortest route to visit 100 different cities, a famous problem called the traveling salesman problem, the number of possible routes just explodes. It's astronomical. Finding the perfect route is brutally hard. But if I give you a route, checking how long it is, simple. Solving is hard, checking is easy. So here it is, the big one. The whole thing boils down to this. Are we sure that distinction is real? Or are all those problems that are easy to check also secretly easy to solve? And we just haven't been smart enough to find the simple recipe yet. To put it formally, does P equal NP? Are these two categories actually the exact same thing? Now, this is where it gets even crazier. Scientists discovered this thing called NP completeness. It turns out that thousands of these hard-to-solve, easy-to-check problems, from scheduling airline flights to folding proteins to designing computer chips, are all connected. They're like the final bosses of the NP world. And if you find a fast, easy way to solve just one of them, you've basically found a master key that unlocks and solves all of them all at once. And nope, this isn't just some academic thought experiment. The Clay Mathematics Institute has put up a $1 million Millennium Prize for anyone who can actually prove whether P equals NP. That's how big a deal this is. This is fundamental to our understanding of what is and isn't possible to compute. So where does the smart money lie on this $1 million question? Well, after decades and decades of the absolute brightest people on the planet trying and failing to find that master key, a pretty strong consensus has formed. The overwhelming belief is that P does not equal NP, that some problems are just fundamentally hard. Okay, but wait, if everybody is pretty sure they're not equal, why can't somebody just prove it and collect their $1,000,000? Well, this is where the problem becomes almost mythical. It's incredibly difficult to prove a negative, and this one seems to be pushing up against the very limits of what mathematics can even do. It turns out there are these massive mathematical roadblocks in the way. It's like the question is protected by these intellectual fortress walls. The normal tools and proof techniques that mathematicians always use, they just break when you try to apply them here. It's been suggested that any valid proof would have to be so strange, so new, that the very techniques used in the proof could accidentally teach us how to break all of modern cryptography. It's a total mind-bending paradox. Okay, so this is all really fascinating for coders and mathematicians, but is that all it is? Is this just about algorithms, or is this about something much, much deeper, about the nature of reality itself? Because the answer to P versus NP, it turns out, has these echoes absolutely everywhere. It asks questions about physics, right? Is the universe itself simple or complex at its core? It asks about economics. Are huge markets just too complex to ever really predict? And it asks about us, about whether there are fundamental limits to what human beings can ever discover.
I mean, let that sink in for a minute. If P equals NP, it suggests a universe where creativity isn't some special magical spark. A brilliant song or a breakthrough scientific theory would be no different than a computer just brute forcing its way through a giant list of options. That eureka moment we all talk about, it would just be an illusion.
But if P does not equal NP, then the opposite is true. It means that complexity is a real baked-in feature of the universe. It means that actually finding a solution is genuinely harder than just checking one. It means the struggle, the frustration, and that sudden creative leap of insight, that's not just a weird thing our brains do. It's a fundamental part of how reality works. And really, that's the ultimate question that P versus NP leaves us with. Is the universe this incredibly elegant, simple place and we just haven't found the key yet? Or is true creative struggle a fundamental law of existence? The answer isn't just going to define our technology. It's going to define our understanding of creativity, of intelligence, and maybe of the universe itself.